In this video, the impact of various circuit and signal parameters on the high-pass filter will be demonstrated. Let's see changes in the high-pass filter response as the value of the resistor is modified with constant values of capacitor at 0.1 microfarad, and input signal sine wave of peak-to-peak amplitude at 2 volt peak-to-peak at a frequency of 100 Hz. With resistor value equal to 1 kΩ, the cutoff frequency of the high-pass filter 1.59 kHz. Since the input frequency is 100 Hz, which is less than the cutoff frequency of the filter, the time response in the oscilloscope shows the output voltage is 160 mV. It's also interesting to observe the output signal of the filter leads the input signal in phase. Now as the resistance is changed to 10 kΩ, the cutoff frequency of the filter reduces to 159 Hz. Since the input signal frequency 100 Hz is closer to cutoff frequency, the output signal amplitude increases to 960 mV and the phase shift between the output and input signal reduces. Now have a look at the changes in the high-pass filter response as the value of the capacitor is modified by keeping the resistor value constant at 1 kΩ. Input sine wave of peak-to-peak amplitude at 2 volt and frequency at 1 kHz. With capacitor value equal to 0.1 microfarad, the cutoff frequency of the high-pass filter 1.59 kHz. Since the input frequency is 1 kHz, which is closer to cutoff frequency, the time response in the oscilloscope shows the output voltage peak-to-peak amplitude is 1 volt. It's also interesting to observe that phase of the output signal is close to that of the input signal. Now as the capacitor is changed to 0.01 microfarad, the cutoff frequency increases to 15.9 kHz. Since the input frequency of 100 Hz is far away from cutoff frequency, the output signal amplitude reduces to 192 mV and the phase difference between the output and input will increase. Let's see the impact of signal frequency on the high-pass filter response by keeping the value of the resistor, capacitor constant at 1 kΩ and 0.1 microfarad respectively. Input sine wave of peak-to-peak amplitude at 2 volt. The cutoff frequency of the high-pass filter is 1.59 kHz. First, with input signal at 100 Hz, the oscilloscope shows the output signal peak-to-peak amplitude of 160 mV. As the frequency increases to 500 Hz, the output amplitude improves to 600 mV and it further increases to 1 volt as the frequency reaches 1 kHz. If the frequency further increases to 2 kHz, the time response shows that output amplitude increases to 1.52 volt, and if the input frequency is 4 kHz, which happens to be in the passband region of this filter, the output amplitude is 1.86 volt and it's almost in phase with the input signal. After observing the time response of the high-pass filter, now let's have a look at the impact of resistor value on the frequency response of the high-pass filter. The capacitor value is kept constant at 0.01 microfarad and the input amplitude is kept at 1 volt. With resistance of 1 kΩ, the Bode plot shows the passband gain of almost 0 dB at 325 kHz and the 3 dB cutoff frequency is 11.27 kHz against the ideal value of 15.9 kHz. One of the important characteristics of the filter that is roll-off is 19.49 dB per decade. If the value of resistor is changed to 10 kΩ, passband gain measured at 16.6 kHz is again almost 0 dB and the cutoff frequency is 1.09 kHz against the ideal value of 1.59 kHz. The roll-off the filter is 19.32 dB per decade. It's also noticeable that phase difference between output and input signal in the passband is close to 0 degree and at the cutoff frequency it is 45 degree. Subscribe to Labsland to explore many more parametric analysis of high-pass filter.